Hello everyone. Today I'm making the new movie in order to continue our chapter content, chapter 5, and we already watched two movies already. So this should be the third movie for chapter 5. Okay, this is the last slide of previous movie. We ending rules audition by this slide, and this slide you have some practice and homework. Okay, this is homework for you. Okay, now we go into new rules. New rules is about rules of multiplication. Unlike rule of addition, the rules of multiplication we have only two sub rules. One is special rule and the other one is a general rule of multiplication. So first we will go to study the special rule of multiplication. Okay, so in order to study special rule of multiplication, it is required us to have at least two events. Okay, in order to study special rule of multiplication, at least we have two events. So in this case we have two events at least, but that means at least two events. It should be 2, 3, 4, 5 or 6, 7 up to or n. Okay, so now suppose that we have two events A and B. We have two events A and B, that A and B are independent events. What does it mean, independent? It means that even A and even B not depend on each other. Okay, even A or even B does not depend on each other. That's why even A and even B are independent events. That means A not depends on B, B not depends on A. So in order to study rule of multiplication, you need to have at least two events. Now we have two. One is A, one is B, and moreover A and B are independent events. That means even A not depends on even B not is not depending on even A. Okay, two events A and B are independent if the occurrence of one event has no effect on the probabilities of the occurrence of the other event. Okay, like I mentioned here, even A and B are independent, the probabilities of A not depends on probabilities of B. Okay, or probabilities of B not depends on probabilities of A. That means the chance of A getting not depends on the chance of B. The chance of B coming does not depends on A. So that's why A and B are independent events. The probability of two independent events A and B is found by this formula. PA and B equal to PA multiplied by PB. Okay, so be careful for this one. When we study rule of addition, it should be add. Okay, we're talking about addition, but now we are studying rule of multiplication. That's why this is multiply. Okay, this is multiply. So the probability of A and even B equal to probabilities of even A multiplied by probabilities of even B. In case we have three independent events A, B and C. A, B and C. So special rule of multiplication between three events together is probabilities of A and B and C equal to probabilities of A multiplied by probabilities of B multiplied by probabilities of C. This is two independent events A and B. So the special rule of multiplication of two independent events A and B equal to that one. And this is three events. So the special rule of multiplication of three independent events is found by this formula. Okay, for that by formula. So okay, this is a short short explanation, and you can go to see example, to study example and do cell review 5.5 on page 159 and 160. Just 159. This is example that you need to see or you need to study. So normally on textbook, when you see example, it always comes with solution. And then 160, you can see cell review 5.5. So this is your practice. Example, this is what you learn from this example, and then you can practice. If you can answer the correct one, that means what you have learned is okay, fine. Okay, this is a example and cell review. Okay, so this is a finish by that for special rule of multiplication. So again, in order to study special rule of multiplication, at least you have two events, that these two events are independent. That's why you can find the special rule of multiplication A and B equal to probability A multiplied by probability B. If you have in case you have three or more than three events, so probability of the first one multiplied by probabilities of the second event and multiplied by probabilities of third one and multiplied by up to the last one. Okay, now we go to second sub rule of multiplication, is a general rule of multiplication. In order to calculate probabilities by using general rule of multiplication, at least you have two events. Okay, at least you have two events. Now we have two events, A and B, but in this case A and B are not independent. A and B are not independent event. What does it mean are not independent? That means A may be depending on B, or B may be depend on A. Okay, so if they are not independent, it is called that they are dependent event. So be clear. If you want to study probabilities of two events, at least two events, these two events using special rule of multiplication, so these two events must be independent. But if you want to study rules of multiplication under general rule of multiplication, at least you have two events, but these two events are dependent event. Dependent event, that means event of 1 depends on of 2, or event of 2 depends on of 1. Okay, it depends on each other. So two events A and B are dependent even if the occurrence of one event has an effect on the probabilities of the second of the occurrence of other. That means the probabilities of the first of one event will have effect on the probabilities of second one. Okay, that's why these two events are dependent events. So When we're talking about general rule of multiplication, you have two events, that these two events are dependent events. So under general rule of multiplication, you need to study conditional probability. Okay, to study general rule of multiplication, because two events, or at least two events, are depend on each other. That's why one event is condition of the other. So under general rule of multiplication, you need to understand a conditional probability. Okay, conditional probability. However, previous video, if you want to study, or when you want to study general rule of addition, previous video, not now, previous video, if you want to study general rule of addition, you need to study joint probability. Okay, so general rule always has special probability. General rule of addition, you need to study joint probability. General rule of multiplication, here you need to study conditional probability. Okay, now what is conditional probability? Conditional probabilities is the probability of a particular event B occurring given that, or under condition that other event has occurred. Okay, so conditional probability is probabilities of one event occurring given that, or under condition that the other event has occurred. So in this case, I can say that probability, the event A come first, then event B come later. So the occurrence of event B or second event can be coming unless or under condition that event A come first. Okay, so in this case, event A come first and then event B coming, but we want to study probabilities of event B under condition of event A has occurred. So how to write a shortcut one? This is the right shortcut one. This is we call probability of B under condition of A, or given that A. Okay, so be careful. So far, some students they write like this one: A, B, like this one. So what does it mean here? This means that event A divided by B. Probabilities of event A divided by event B. If you write like this one, divide it, okay? Be careful. So this is wrong. Some students so far they wrote, or they express this style. This is wrong. Okay, this is just a straight line, not a steeper line like this one, a straight line this one. It should be, I can say, a vertical line, not steeper line. Okay, this one is not, this one is okay. So I hope that you will not confuse this one. Don't write this way. Okay, don't write this way. This is not conditional probability. Be careful, I said again and again. Okay, be careful, I said again and again. Even though previous years I said again and again, but still some students still coming with, I don't know how to say. Okay, I don't know how to say. That's why I expect that you are not follow them. Yeah? You are not the one who follow them. So don't do this style. but you need to do is this style. Probabilities of B given that. Probabilities of B given that A. Okay, or probabilities of B under condition of even A. So this sign we read given that or under condition that. Given that or under condition that. Okay, so don't make a wrong expression. Don't make a wrong expression. This is correct one. This is wrong one. Wrong. This is correct. Okay, so I show many times because I don't want to see again and again the wrong always coming. Why I don't know why some student they still like the wrong way. Okay, so this is, I hope that all of you will get the right way to express conditional probability. Okay, so conditional probability refer to probabilities of one event happening. It depends on or it under condition of or given that probabilities or the other. Okay, general rule of multiplication is used to find the joint. It's used to find the joint probability. Okay, used to find the joint probability that we learned from previous movie. Okay, general rule of multiplication is used to find the joint probability that two events will occur. It states that for two events A and B, the joint probability that both events will happen is found by multiplication or multiplying the probability that event A will happen by the conditional of probability B under condition or given that probability or event A has occurred. Has occurred, that means A already happened. A already happened and then B. Okay, so be careful. A has occurred. So A already occurred or A already happened in the past, not now. Now is B. Okay, so be careful that one. So the formula for general rule of multiplication that we use in order to find the joint probability is that way. Probabilities of A and B for general rule. Probabilities of A and B equal to probability of A multiplied by probability of B under condition or given that A. Okay, so in this case, probability of A, there's no the other depend on A is not depend on the other because A is the first event. Normally the first event is not depend on the other, but the second event, the third event, the fourth event, and the last and the last event is always depends on the previous event. Okay, so in this case, this is we call general rule of multiplication A and B. But if you write like this one, this is probabilities of A and B equal to probabilities of A multiplied by probabilities of B. This is also rule of multiplication of multiplication, but not general rule. This is special rule. Special rule because A and B are not depend on each other. If A and B are not depend on each other, they are independent. But general rule, A or B depend on each other. In this case, normally A always comes first. That's why A not depends on the other, but the other depends on A. Okay, A not depends on B or C, but the other B or C depends on A. Okay, be careful. So I said many times because I don't want you to confuse this one. In case we have three events, probabilities of A and B and C equal to probabilities of A multiplied by probabilities of B given that A multiplied by probabilities of C given that B and given that A. Okay, so this is three events. How about four events? Okay, if our four events, for example, probabilities of A and B and C and D, so equal to probabilities of A multiplied by probabilities of B. So this is probabilities of B given that A multiplied by probabilities of C here given that B and A and multiplied by probabilities of D given that C and B and A. Okay, so this is in case we have four events, A, B and C, A, B, C and D. Okay, for example, now study example. This is for general rule, but however I will make two cases, general rule and special rule together. But now look at this one. For example, a golf player has 12 shirts in his closet. In his closet, 9 are white shirts, the other are blue. How many the other? 3. 3 plus 9, 12. That's why the other are blues. The other are blues, that means three shirts are blue. Like this one, see? 9 shirts and 3 are blue. He gets dressed in the dark room or in the dark environment. Why we say this one? In the dark, that means he cannot see anything. Okay, he cannot see anything. He cannot see which one is white, which one is blue. He cannot recognize. He cannot see which shirt is blue, which shirt is white. That's why it means random. He select or he get the shirt in his closet without seeing anything. Okay, without seeing anything. That's why randomly he selected. Okay, so this is the mean that he select randomly because he cannot see. He cannot recognize which one is white, which one is blue. So he just grabs or get a shirt and puts this shirt on him, and he plays a golf 2 days in row. 2 days in row. So the first day and second day in row. For one condition, for the first condition, does not do laundry. What does it mean? Does not do laundry. That means these 2 days playing, he used or he put on new shirt. New shirt. One day one shirt, the other day the other shirt, because not laundering, not washing. Okay, so he put on one shirt for one day and the other shirt for the other day for the other shirt, not the same shirt for the first day, because not laundering. Okay, so not laundering, that means he put one shirt today, next day he put the other shirt. This is the first condition. Second condition, he played golf 2 days in a row, first day, second day, and do laundering. Do laundering, that means he after finishing playing today, he takes this shirt, go to laundry and put into closet, and next day he get the shirt from the dark place again, dark environment again. So one do not laundry, as again one is laundry. So this is information given. This is a question. What is the probability of 2 white shirts selected? What does it mean? 2 white shirts selected. That means the first day white, second day still white. Because he plays 2 days in a row, first day, second day. And for the first condition, not laundering. For second condition, laundering. So I mentioned already laundering. What does it mean? After finishing playing the first day, he does not take this one for washing. So next day he will get new one. But with laundering, that means after playing for the first day, he got the shirt, go to wash, and then get into the closet. Next day, tomorrow, he goes to closet and take one randomly again. Okay. So we have 2 day play. He have 2 day playings with 2 conditions. Now 2 day playing again, the same information. 2 day playing again, 2 conditions again, but different question. Now the question, what is probabilities is 1 white and 1 blue shirt selected. Previous one, both shirts are white. But this one, the same information, 2 days in row. But what is probabilities of 1 white selected and 1 blue selected? 1 white and 1 blue selected. The other day, suppose that now he playing 3 days, not 2 days after previous one. He playing 3 days in row, day 1, day 2, day 3. And the first condition, do not laundry. Second condition, laundry. And the question is probabilities of 1 white and 2 blues. Okay, 1 white shirt and 2 blue shirts selected. Okay, so I have how many questions based on this one? 6 questions. Okay, 6 questions. This is 2 questions. This is 2 questions. Don't think only one because I see only one. No, it's not 1 question. It's 2 questions. This question based on the condition, 1 question. This question based on this condition, the other question. That's why this is 2 questions. This is also 2 questions. This is also 2 questions. So total 6 questions asking. But however, I will answer 1 question among 6 questions for you. Okay. Okay. Now go to the probabilities of both white shirts selected under condition of, in the case of does not laundry. In the case does not laundry. Okay, so probabilities of 2 white shirts selected in case 1 does not laundry. This one. Both white shirts selected does not laundry. Okay, so I will make an answer for this one. Now in order to answer, we just setting. Okay, we set W. This is a shortcut because if we say Y is long one, take long time. So don't try to take a long time. Just make a shortcut. So I just I set W for white shirt, B for blue shirt. The event that we study is playing day, golf playing day. So I just say day. The event is about day, a golf playing day. That the first shirt selected is white, I will put W1. Y1 is first day. So the probabilities of the first white shirt selected is 9/12. Okay, why is it 9/12? Because in the closed set, how many white shirt? 9. Okay, because we want to see, we favor to see Y. That's why how many Y that we want to see? 9 among total 12. The event that second shirt Y2 W2, the event that second shirt W2 is selected is also Y. In this case, the probabilities of second shirt selection is Y is the conditional probability. In this case, the probabilities of second Y selected, second Y shirt selected is conditional probability. Given that the first Y shirt is also selected. Given that the first shirt selected is also white. Okay, so the the probability of second Y selected is conditional probability, because second Y shirt selected, it depends on the third Y, it depends on the first Y shirt selected. So in this case, we can use this style, use this symbol. The probabilities of W2 given that W1 equal to 8/11. Why is it 8/11? Because in the closed set there are 9 white shirt, and the first day he take 1. If he take 1, how many left? 8. Okay, 8. And total, the first day total 12. If we take 1 off, how many left in the closed set? It's only 11. Okay, it's only 11. That's why the second white shirt is affected from the first white shirt selected. In this case only if he does not do laundry. Okay, but if he do laundry, what happened to second white shirt? What happened to second white shirt? Okay, so I think that you can get this point. To determine the probabilities of 2 white shirt being selected, we use formula this one. This is general rule of multiplication, because the second Y selected, it depends on the first Y selected, Y shirt selected. Okay, so probabilities of W1 and W2 equal to probabilities of W1 multiplied by probabilities of W2 under condition or given that W1. Okay, so 55%. So who can explain what does it mean 55%? What does it mean if 55%? Okay, now my answer is already finished. The answer, what is probability of both Y shirt selected in case he does not go to laundry? Not go to laundry, okay, to laundry. Okay, this is, you have a cell review 5.6. You can go to your textbook on page 162. And how about the other question? The other question for you to do. Case 2. So answer the same question but case 2, because I answer case 1 already here. This is case 1. The same question but case 2 is for you to answer, and the other one, probabilities of W1 and B1 selected for 2 cases. Do not laundering, and the other cases do laundering. Laundry, not laundering. This is probabilities of 3-day play in row, probabilities of W1 and B1 and B2 for 2 cases. The first does not laundry, and second one do laundry. Okay, so I think you can do it and you can find the answers. I'm waiting to see your answers for that one. Okay, we continue our rule of multiplication. In order to use rule of multiplication, especially general rule of multiplication, sometimes we can use table data in order to study the probabilities of something based on this table data. The table data that given us the data for study we call a contingency table. A contingency table is a table used to classify sample observations according to 2 or more identifiable characteristics. So contingency table is a gross tabulation table. It's a gross table or a gross tabulation that simultaneously summarize or describes or that means tell us 2 variables of interest and their relationship. That means 2 variable interest and 2 variable relationship. For example, a sample of executives were asked about their loyalty to the company. Okay, a sample of executives were asked about their loyalty to the company. The question could be asked, if you that means executive, if you were given an offer by the other company equal to or just slightly better than your present position, would you remain with the company that you work in, or you take the other position from a new company? Okay, the other position, new company. That means remain. Would you remain, stay the same company, or you take the new position in new company? So in this case, we have suppose that we have 200 executives in our sample data set, and ask these 200 executives this question. And so after asking, we got a result like this one. So we are 200 executives. After finishing collecting their answer, we found that 120 stay the same in the company, 80 will move to new company. That's why in this case we just said A, the answer remain the company or not remain. Not remain, that means this move to the new company. So A1 stand for stay or remain in the company. A2 stand for not remain, then move to new company. Okay, among all executive, we also classify them by length of service. That means the period of time they are working. So let's see, the executive that answer stay the same, 120. 5 working less than 1 year, oh sorry, not 5, 10 working less than 1 year, 30 work from 1 to 5 year, 5 work 6 to 10 years, 75 work more than 10 years. Okay, this is among the executors say that they will stay the same company. 10 of them work less than 10 year, 1 year, 30 work 1 to 5 year, 5 work from 6 to 10 year, 75 work more than 10 years. However, the executive that not remain, that means move to new company, 80 executive move to new company. Among 80 of executive not remain, they move to company. 25 work less than 1 year, 15 work 1 to 5 year, 10 work 6 to 10 year, 30 work more than 10 year. Okay, so this is the question. Based on this table, the question should be asked. So I have question 1. Next we will have question 2. Question 1. What is the probability of randomly selecting N of one executive who is loyal to the company, that means would remain, and who has more than 10 years of service? Okay, so what is probability that randomly selecting one executive who is loyal, who would remain in the company and work more than 10 years? So in this case, we will find the probabilities are A1. So the probabilities are A1 equal to 120 divided by 200. Why 120? Because A1 stands for would remain the same, would remain with the company. That's why based on the table we can see that 120 executive say that they would remain with the company among all executive asked. Okay, so B4, why we need to find B4? Because based on the question, would remain A1 more than 10 years before. Okay, so we will find A1, probabilities of A1 and probabilities of B4 only, because the question asks only these two events. Okay, the event of B4, there are 75 executive among 120, not among 200. Why not among 200? Because our question asking remain with the company and work more than 10 years. That's why work more than 10 years should depend on remain. So that's why 75 out of 120 with the company, remain with the company who has 10 years of service. That's why here this is we call conditional probability, because B4 depends on A1. B4 depends on A1. Okay, it is A1. So 75 over 120 equal to this 0.625. So the probabilities of randomly selecting an executive who will remain with the company and who has more than 10 years of service is probabilities of A1 multiplied by probabilities of B4, given that A1 equal to this one. Oh, okay. 0.375. So this is the answer of question number 1, because number 1 asking about n. Now what asking about n. Okay, so now should be the ending slide for this movie. I will go to question number 2. We'll go to new movie. Okay, now let's turn to you for watching and work, study and work. Because why study? You watch and you study. Why work? Because I have some question for you to find the answer. That's why you need to work in order to find the answer.